Hi, welcome to my channel. In this video, we want to find all real solutions of the following system of equations. 3 over xy equals x over z plus 1. 3 over yz equals y over x plus 1. And 3 over zx equals z over y plus 1. And now for the solution. First, observe that the variables on the right hand side of the equations are of the form x over z, y over x, and z over y. With this in mind, let's make the substitutions a equals x over z, b equals y over x, and c equals z over y. Let's try to express the first equation in terms of the new variables. Multiplying the numerator and denominator of the left hand side by z, we then write the equation as 3 over zx times z over y equals x over z plus 1. Substituting 3 over zx equals z over y plus 1, we obtain z over y plus 1 times z over y equals x over z plus 1. Since a equals x over z and c equals z over y, we have c plus 1 times c equals a plus 1, which expands to c squared plus c equals a plus 1. For the equation 3 over yz equals y over x plus 1, after multiplying the numerator and denominator of the left hand side by x, we then write the equation as 3 over xy times x over z equals y over x plus 1. Substituting 3 over xy equals x over z plus 1, we obtain x over z plus 1 times x over z equals y over x plus 1. Since a equals x over z and b equals y over x, we have a plus 1 times a equals b plus 1, which gives us a squared plus a equals b plus 1. Similarly, for the equation 3 over zx equals z over y plus 1, we multiply the numerator and denominator of the left hand side by y. We then write the equation as 3 over yz times y over x equals z over y plus 1. Substituting 3 over yz equals y over x plus 1, we obtain y over x plus 1 times y over x equals z over y plus 1. Since b equals y over x and c equals z over y, we have b plus 1 times b equals c plus 1, yielding b squared plus b equals c plus 1. Next, we add the three equations to obtain c squared plus c plus a squared plus a plus b squared plus b equals a plus 1 plus b plus 1 plus c plus 1. After rearranging, we obtain a squared plus b squared plus c squared plus a plus b plus c equals a plus b plus c plus 3. After subtracting a plus b plus c, this simplifies to a squared plus b squared plus c squared equals 3. Let's analyze the expression on the left hand side using the AMGM inequality. Given non-negative variables a1, a2, all the way to an, the AMGM inequality states that the arithmetic mean given by the sum of the variables divided by n is greater than or equal to the geometric mean given by the nth root of the product of the variables, with equality if and only if all the variables are equal. Multiplying n to both sides of the inequality, we obtain the sum of the variables is greater than or equal to n times the nth root of the product of the variables. For our case, n equals 3, a1 equals a squared, a2 equals b squared, and a3 equals c squared. So we have a squared plus b squared plus c squared is greater than or equal to 3 times the cube root of a squared times b squared times c squared, with equality if and only if a squared equals b squared equals c squared. To proceed further, we need to evaluate a squared times b squared times c squared. Using our substitutions, a squared times b squared times c squared equals x squared over z squared times y squared over x squared times z squared over y squared. Simplifying the expression, we see that x squared cancels out. Similarly, y squared and z squared also cancels out. So we obtain a squared times b squared times c squared equals 1. Thus, the right hand side of our inequality is 3 times cube root of 1, which is 3. Since the variables satisfy the equation a squared plus b squared plus c squared equals 3, and we showed that the left hand side of the equation is greater than or equal to 3, and equals 3 if and only if a squared equals b squared equals c squared. Therefore, we have a squared equals b squared equals c squared. Substituting b squared equals a squared and c squared equals a squared into the equation a squared plus b squared plus c squared equals 3, we obtain 3a squared equals 3, which simplifies to a squared equals 1. Therefore, we have a squared equals b squared equals c squared equals 1. Let's bring back our original equations. A squared equals 1 implies a equals minus 1 or a equals 1. Consider the case when a equals minus 1. Then since a equals x over z, we have x over z equals minus 1. Substituting this into 3 over xy equals x over z plus 1, we obtain 3 over xy equals minus 1 plus 1, which is 0, resulting in the system of equations having no solutions. Similarly, b equals minus 1 and c equals minus 1 will result in the system of equations having no solutions. Therefore, we have a equals 1, b equals 1, and c equals 1. Taking note of our substitutions, when a equals 1, we have x over z equals 1, which implies x equals z. When b equals 1, we have y over x equals 1, which implies y equals x. When c equals 1, we have z over y equals 1, which implies z equals y. Combining the results, we therefore have x equals y equals z. Substituting y equals x and z equals x into 3 over xy equals x over z plus 1, we obtain 3 over x squared equals 1 plus 1, or 3 over x squared equals 2. Cross multiplying gives us x squared equals 3 over 2. Thus we have x equals square root 3 over 2, or x equals minus square root 3 over 2. Therefore, the solutions to our original system of equations are x1, y1, z1 equals square root 3 over 2, and x2, y2, z2 equals minus square root 3 over 2. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.